Okay, so before we start talking about finding the ith biggest number, let's look at two easier problems here. Let's start with finding the minimum and the maximum. So what I want you to do is write an algorithm out in pseudocode for finding the minimum and maximum numbers. Well, I imagine you'll end up with something that looks sort of like this. We are just going to loop over all elements in the array. One little minor optimization here, if you can even call it that, is I'm just going to start my min val at equal to the first value in the array. So this assumes we have at least one value in the array. And then I loop through and I compare to all other values in the array. So from 1 up to, but not including n. Then I just return the min value. The only difference over here is that I've called it max value, and I'm using a greater than symbol instead of a less than symbol. So pretty simple. But let's build on this, and let me ask you next, what would an algorithm look like for finding the second order statistic? So that would be the second smallest number. Okay, well, you don't have to have come up with exactly this algorithm, but let me give you an example of sort of an optimized way to find the second order statistic. And this is pretty general. This will work for more than just the second order, but it's easiest to show with the second order. So let's say we have our array, and it has some number of elements. Well, a good algorithm for doing this is to compare all pairs of numbers. So we're going to compare these two numbers and take the smallest. So for every pair, do the same thing. So how many comparisons is that? That's going to be n over 2 comparisons so far. And then I can compare those. So I can compare these to the winner of these two and the winner of these two. And by winner, I'm going to mean that I'm going to take the smaller. So since we're looking for the second smallest number, let's say that the smaller of the two numbers is the winner. And then I do the same thing here. Actually, first let's see how many comparisons did I make here. So I made n over 2 comparisons the first time. How many comparisons did I make at this second level here? Well, I've made 4 comparisons. 1 here, 2, 3, and 4, and that gave me 4 new numbers. So that was n over 4 comparisons at that level. And then here I'll do n over 8 comparisons. And then finally I'm left with just 2 numbers. I'll compare those two, and that will give me the min. And so I've done n over 16 comparisons there. So just one more comparison. Okay, well, now I have the minimum value. How do I find the second value? So where does that second value come from? Or from where does it come? So let's just say, for sake of example, that this was the minimum value, which means it ended up here, 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 and then here. What can you tell me about the second smallest value? Well, the second smallest is the second smallest in the entire array, so it had to, the only thing it could have lost to is the minimum value. So it had to be compared to the minimum somewhere along the way. So it had to be either this one, or this one, or this one, or this one. Those are the only elements that could have been the second smallest, because they're the only ones that lost to the minimum value. And how much work does it take to find that value? Well, if we save the losers from each comparison and a set that is associated with the value itself, so this value min has a set of everything that it beat, and then we just find the minimum of that set, we have our second smallest value. So we would come back up through here and we would say, okay, let's say this is the second smallest value, and then we'll compare it to this one, and then we'll compare the winner of those two to this one, winner of those two to that one. And what's the total number of comparisons there? So going from sort of the bottom of this binary tree back up to the top of this binary tree, how many comparisons do I have to take as I go back up the tree? Well, this is a binary tree, so that's going to be logarithmic. Log n to go back from the base up to the top. So that means we've done a total of n minus 1 comparisons plus log n comparisons, which is pretty good. It's less than 2 in total comparisons. Where did I get the n minus 1 for? This an identity for this general series here, where you're dividing all the way down to one element. So I've got n minus 1 plus log n total comparisons for our finding the second order statistic. So why do I bring up finding the second order statistic? Just to show you how sort of tedious it can be to end up with a linear algorithm using this kind of method. And this is linear because if I'm looking at this equation here, the highest order term there is going to be n. So this log of n term on the far right will be sort of subsumed by n. We've got a linear algorithm there. What would it be like if we were trying to find a third order statistic from this? Well, we'd have to go through this tree and figure out which was the second smallest element, and then see what all got compared with the second smallest element and the smallest element, because those are the only two things that could have gotten beaten. Point is, this is not very general. If my discussion there about finding the third smallest element didn't sit right, maybe listen to that again. I did go over it pretty quickly. It's not extremely important that you understand that, just because I just want to make the point that it's not a very general algorithm for finding the nth order statistic, the ith order statistic.